Hello. In this pandemic situation, it's difficult for the students to reach out to college and perform experiments in the laboratories. So this is my sincere effort to that is make you understand the experiment in that is audio video engineering, where it is the experiment related to analysis of a composite video signal for a color television using the pattern generator. So this is the that is the content, or we'll say the title. That is to observe the composite video signal using a color television pattern generator. Now, as I said, it is a pattern generator. What is first a pattern generator? I think you are aware of composite video signal. It is a combination of audio video signal with the synchronization pulses also. It is horizontal and vertical synchronization pulses plus the we'll say video signal and the audio signal which are being combined together. We call it as a composite. That is the signal which has been formed by. When we say it is a composite video signal, then it is nothing but the video signal contains such as the video information, the back port, the sync pulse, then it is the front port, then it is a color burst signal, which is contained in the composite video signal. Now, what is a pattern generator? Now, a pattern generator is nothing but an equipment which is used by the that is for the service and maintenance and alignment of a color television receiver. Not a color television, it's specifically any television receiver you can use it, right? What does this generate? It generates a video signal, that is a composite video signal, and an RF signal. RF signal is generated at VHF1 and VHF3 band, right? The band frequencies for band 1 is 41 to 68 megahertz, and for band 3 is 174 to 230 megahertz. So the signal has been generated, that is a video signal for different, that is the patterns it has been generated. What are the different patterns is? The patterns are nothing but a color bar pattern. You are aware that is when there is nothing but transmitted from the transmitter side, your television on your television, you will see different color bar patterns, right? So this is nothing but a pattern which has been generated so that you can test your receiver set, that is whether we are receiving exactly the same color pattern which has been there, right? So the testing and alignment of a television receiver is been done by using this particular pattern generator. With color bar pattern, there are different patterns also, such as we'll say vertical bar pattern. There is a horizontal vertical bar combined pattern bar pattern. Then it is a dot pattern, that is every that is you can say if it's a crossbar, then at every cross there is a dot which has been generated, and that is nothing but a pattern, that is a dot pattern. Then a total white pattern, a black, different patterns are different colors also, like we'll say red, green, magenta, cyan, etc. So this with these particular patterns, there is a testing been carried out on your receiver, and the alignment is also done at your receiver side. What are we going to study in this experiment is nothing but we are going to analyze the different composite video signals for the different that is the patterns using an oscilloscope and a pattern generator. Okay, so let's start. I have a pattern generator which I have shown here. It is a Syntec color television pattern generator. So its model is 2670 pattern generator. Now what you can see is it contains the different that is the bar that is the patterns which have been generated. Which are these patterns which you can say is these patterns are nothing but that is a color bar pattern which is shown over here. A red pattern, a total red pattern. It is total white. Then this is the dot pattern. Then these are the horizontal vertical lines which have been there with background equal to white. Then this is horizontal vertical lines with background black, and the lines are nothing but that is a black line. These are horizontal lines. Then this is a crossbar pattern. That is a crossbar pattern. So these are the different color patterns which have been there. How to select these particular patterns is from these particular switches. You want selecting, that is pressing this particular switch, you can select the patterns itself, right? So this is the power on for the pattern generator. We have two outputs which are from here. One is the video output and the second one is the RF output. So you can directly test your signal at the band frequencies, that is for band 1 and band 3. This is the RF signal which has been generated. You need to select it. So if you that is switch on the in the upper position, it is band 1. In the low position, it is band 3. While video signal is a composite video signal which can be generated. It's a ready composite video signal which can be generated and can be seen for the different bar, that is the patterns which has been there. So this is the color, that is a pattern generator. Now you have a setup which I have used shown here for this particular pattern generator. What is a setup is you contain, this is showing you a CRO and a pattern generator which has been there, right? So what has been connected is I have connected the video output. Directly what you do is take two, that is a CRO probes, connect the channel, that is channel 1 of the CRO probe directly to the channel that is the video output. And what you can see is the pattern you need to select here. What pattern I have selected here is, see, there is a highlighted, that is a LED over here. So the pattern selected here is nothing but the color bar pattern. So what you can see here on the CRO is the, for the color bar pattern, how is the video signal going to look like? Okay. So this is the shape of the video signal which is looked on the CRO. Now I'll analyze how the video signals will be looking for. That is, a composite video signals will be looking for all the different patterns. So one by one, we'll analyze the composite video signal, right? Now, before starting with the composite video signal, this is just an observation for what you can see is this is the composite video signal, a general composite video signal, where you can see that is 4 to 5 components of this particular signal. The first of all, we'll go through the picture information. So this is the random picture information which has been that is shown for the video signal. Then this is the back porch of the composite video signal. It contains a color bus. What is a color bus? It's 8 to 10 cycles of color subcarrier which has been generated to recover the color information at the receiver side. And hence at every back porch of synchronization pulse, that is a horizontal synchronization pulse, we transmit this particular, that is the 8 to 10 cycles of color bus. The carrier will say. This is a sync pulse and this is the front porch of the horizontal sync pulse. So you can say a horizontal synchronization pulse contains 3 parts, that is front porch, a sync pulse and a back porch. And in the back porch, what has been displayed is, that is transmitted is nothing but a color bus. And this is nothing but the video information. So for every now composite video pattern, we'll see, sorry, for every pattern, we'll see the composite video signal which has been, that is displayed here. So the first pattern which I have selected is the color bar pattern. So what you can see is, this is the color bar pattern. This is the standard color bar pattern which has been generated. You can see white, yellow, and then it is the last one is nothing but black. So what you can see is, for this color bar pattern, how is the composite video going to signal look like? So you know that when the line is being scanned from this left hand to right hand, it goes on scanning the information. What information is there? This is the white information. So what you know is a composite video signal. This is a negative modulated composite video signal. Why? Because your synchronization pulse is placed at a 0% and you'll say video information at a 100%, right? So what you have is, this is the video signal that is corresponding to whom? White. Because if I scan this particular line for this particular duration, it is nothing but giving me white information. So that white information you can see here. Next is nothing but the color information. So this is your color, that is the chroma signal corresponding to yellow which has been displayed. So this is, we call it as a modulated carrier which has been shown for the color. Now this composite video signal contains the luminance information and also the color information. So every color information will contain also the luminance, but now here it is difficult to show the level of the luminance in this composite video signal, right? So what has been shown is, see, this is the level of white in whom, that is the white color. So it's the luminance, that is brightness, which has been related to white itself, right? Then every color will have its luminance, and see here, the level of black which has been shown. So this is the black color, and these are the color informations for every patterns which has been shown. 1, 2, 3, 4, 5, and 6 colors. So it is 1, 2, 3, 4, 5, and 6. The information related to color which has been displayed over here. You can see here, this is the color burst signal. That is the 8 to 10 cycles of color burst to retrieve the color information. So every back porch of synchronization, horizontal synchronization pulse, you'll see this particular, that is 8 to 10 cycle, that we call it as a color burst signal, right? So see, next that is next line information. You can see again a next, that is color burst. same information is repeated every line, and hence same waveform will be repeated, right? So this is for the color bar pattern. Now we'll come for a random video signal. Any random video signal is there displayed on your that is a television. Not only the bar pattern, but any random signal. So for this random signal, the information will be random. So this is your video information, which is random in nature. As per the intensity of the color, the video information amplitude will change. Correct? Waveform will change. This is your color burst. This is again your color burst. That is in the next synchronization pulse. So this is your synchronization pulse, color burst in the back, and this is your front porch which has been seen, right? So this is for the random video signal. This is total white pattern which has been there, right? So total white will be on the top. That is 75% will be total white, and we'll say 12% is going to be black level which has been displayed, right? Between 10 to 12% there is no information which has been transmitted because it's a we say that it is a brighter than bright level which has been indicated, and hence in that level we do not transmit any signals itself, right? So this is what you show, that is a white. So every line you scan, it's totally a white information. So for one line it is total a white voltage level which has been displayed for whom, that is a composite video signal. Again I come to the next line to scan. What is the next information? Again it is a white line, so it is nothing but a white line which has been displayed, and this is the, that is the color burst which has been shown. So this is for white pattern. Okay, then this is for black. That is total the screen displays is black. So you can see the level has been dropped down. That is what it is. It is a black information which has been displayed. These are the observed waveforms on the CRO which have been displayed here. So you can see a synchronization burst, a color burst. Now see, in a pattern generator, there is an option which has been provided to turn on and turn off of that is the color burst. It is not in all pattern generators, but there are some options which are provided on the pattern generator. So if you turn off the color burst, then it is nothing but you're transmitting only black information. That is black and white information. But if you turn on the color burst, then it shows that it is a color transmission which has been there. So here what you can see, though information is total black, but it is the color transmission. So it is containing combination of RGB. So there is a color burst which is going to be present over here, right? So even though information is black, the transmission is nothing but color transmission, and hence you need to transmit, that is a color burst signal itself. So this is for the black pattern, that is level is below. So it is total black. If it is white, it could have white. It is nothing but the highest level, that is white, which has been added. So we come to the next information, that is the green pattern. So here green, it is a color. So as I said, it is a modulated signal, and hence it is going to be the carrier for that particular color which has been displayed. So it's a green. So it's going to be all the line is nothing but displaying the color. So that is green color, and hence it is a single level showing that it is a color information, that is a green color, right? Again, you can see the color burst in this particular pulse as well as in this particular pulse. That is at the back porch of the synchronization pulse. Similarly, you can see for the blue pattern, right? This is again for the blue pattern, that is it is same level of the signal for one line information. Again, the color burst seen at the back porch. So this is regarding the different patterns which has been generated. With this particular, that is the pattern search, so there are different waveforms which are being observed on the color television, and these are horizontal, that is the oscillator output, vertical oscillator output. I'll just try my next attempt to show you all these waveforms across. Okay, thank you. Thank you for listening to me. Kindly like the channel and subscribe the channel. Thanks a lot.